Okay, so now we're ready to dive into the wild, wacky world of hypothesis tests. And again, I'm just going to emphasize that the hypothesis tests we're doing this week are only on population proportions, and we're going to do the same process next week when we're talking about hypothesis tests on population means. So population proportions are a little easier to understand as far as the hypothesis tests. And this is a really good module to understand well because the basic concepts that you learn this week will make next week's work much, much easier in this course in general. Okay, so to start off with, we want to figure out what our hypotheses are given a statement, given a statistical problem. And we want to go back to this picture that we're going to think of the two hypotheses as the two competing claims in a court of law. So we have our sample, and we're trying to decide between two possibilities based on this sample. The first possibility is the null hypothesis is true. And this says that no change has occurred. The sample comes from the population where we know what the percentage was in the past. The other possibility is the alternative hypothesis. It says, no, something did happen, things aren't the same, and now this sample comes from a population that has a different parameter than the value pi naught. So we're trying to figure out which of these two populations does our sample come from. Again, how do we know what these values are? Okay, remember that with a null hypothesis, we have an initial belief based on either past information or just kind of our common sense notion of how things are. And that informs us as to what the value of the parameter is by default, if no change had occurred. The alternative, again, is saying the opposite of the null. It's what we're trying to prove. This is the key point. This is the whole purpose of the study. And we could be testing a claim or a belief about the parameter's value. How we write it. And so this is an important piece of notation that you really want to make sure you understand. This is the notation for the null hypothesis. And let me step you through this. H sub 0, it stands for null hypothesis. So this is read as the null hypothesis says the population parameter has the value of whatever pi naught is. The alternative can have three different forms. We can be trying to prove that the true parameter value is less than the default parameter value, it's not equal to, or it's greater than. And we're going to talk about these different types of hypothesis tests and how this affects our work. So if we look at the three types of hypotheses, okay, I want to look at these three types of alternative hypotheses. The first says that the parameter value is less than the value we believe to be true under the null hypothesis. And this is called, for reasons that we'll explain later, a lower tail test. On the other hand, we can be testing to see if the parameter value has just changed from the default parameter value, pi naught. And this is called a two-tailed test. And finally, we can be testing to see if the parameter value is greater than the value that's believed under the null hypothesis. And this is called an upper tail test. And these names come from when we compute the percentiles of our sample percentage. We're going to see that the percentile we compute is going to be a lower tail. Here it's going to be two tails, and here it's going to be the upper tail. Okay, so one of the things that we want to know going into trying to identify hypotheses is that generally it's easier to identify the alternative. And the reason why is the alternative is the purpose for the study. And therefore, it's usually in the question or in the problem statement to begin with. Okay. We have to pay careful attention to wording. How do we determine which of these three tests we're doing? So if we're doing a lower tail test, we're testing to see if the population percentage is less than the value that it used to be, we're going to see words like decrease. Did the population percentage decrease? So some sort of wording to indicate that. If we're testing to see if it's not equal, we're testing for a difference or a change. In other words, we're not saying in which direction we think it changed. Just the generic word change indicates that the alternative is pi is not equal to pi naught. And again, if we're looking for an upper tail test, it's like a lower tail test. There has to be wording to indicate that the population percentage we're testing to see if it went up. There are some implied conventions in hypothesis testing. Whenever we're testing a manufacturer's claim, we're testing against the claim. That's the alternative. That's what we're trying to prove. When we're trying to prove that populations have a certain property, the default or the null hypothesis is that they do not have. And so we were kind of creating this sequence of steps we should use when we work a hypothesis problem, a hypothesis test. And so first we understand the context. We've already gone through that part. And now we're going to form the hypotheses. It's always a good idea to try to classify your problem into one of these three scenarios. Am I testing to see if a parameter value was affected by a change? Am I testing a manufacturer's claim? Or am I testing to see if a population has a certain property? Also, it's important to realize that when we're trying to find the hypotheses, when we're trying to form them, again, it's almost always easier to identify the alternative because it's what you're trying to prove. It's going to be the question or the problem statement. But we also have to pay careful attention to the wording to see what type of alternative test are we doing. So let's go ahead and do a sample problem just so we get some practice in learning how to form hypotheses. We talked about this motorcycle scenario before. So in Florida, 80% of the motorcycle accidents resulted in injuries prior to 2000. The state instituted a mandatory helmet law in 2000 and wanted to see if the percentage of accident injuries has changed. And so let's go through this process of setting up how we do a hypothesis test. First, we identify the parameter. And the parameter is easy because it's either going to be a percentage or an average or mean, depending on what type of variable we're working with. And here we can clearly see there's no mention of an average or a mean. We see percentages. So we're working with a population percentage. Next, we go to the variable. Percentage of what? That's the variable. And it's the percentage of motorcycle accidents, okay, that resulted in an injury. So we can see that right from the problem statement. What is the category of interest? So very often binary categorical variables are yes or no. They were in an accident. They were injured or not injured. So clearly we're interested in the case where they're injured. And who are we interested in? Well, this change occurred in Florida. So we're interested in just Florida motorcyclists. So now we have a good idea of what this abstract parameter pi is. We know that pi is equal to the percentage of all motorcycle accidents in Florida that resulted in an injury. And it's always good to write out what you think the parameter is, okay, just so you have your bearings. Now we have a good understanding of what's going on in the problem. Now we're ready for our next step. What type of hypothesis test are we doing? Are we looking at a situation where a change occurred and we want to see if that percentage of motorcycle accidents in Florida resulting in injuries changed? Are we testing some sort of manufacturer's claim? Or are we saying that some sort of population, the Florida population, has some certain property? Well, in this case, we know that the law was passed and we're interested in looking at what happened after the law was passed. So clearly, we're looking at a change occurring. So what is the alternative? So we know that this is the percentage under the null hypothesis, right? And so the null is always going to be written as pi equal to 80%. But now we have to look for the alternative, right? So we're testing to see if we're trying to find out if the percentage decreased, if it increased from 80%, or it changed. And again, the problem statement, well, what do we want to do? We want to see if the percentage of accidents that resulted in injuries has changed. So clearly we're testing to see if it's not equal to, because we see the word changed. And the null is always going to be equal to. Okay? If we can show equals to, we've always established a null. That's sufficient. And this part is important. This is how we write our answer when I ask you to form the hypotheses in the homework. The null is that the percentage didn't change, it stayed the same, and the alternative is that it did. Okay, let's look at our next example, which was the toothpaste ad where Colgate claimed 4 out of 5 dentists recommended their particular brand. And so, first of all, we have to understand the context. Now, I want to say a word about this. At the end of this part, we determine the context. I'm going to talk a little bit about why this ad was misleading and the FDA actually made Colgate remove this ad. They couldn't run it any longer. So again, we're looking for the parameter. Now, we don't see a mean and we don't see a percentage, but we see a proportion, 4 out of 5, right? So again, we know we're looking at a population percentage. That's why sometimes it's called population proportion. A proportion is just kind of a rate, right? Percentage of what? You know, the percentage that recommend it. Are we interested in whether they do or don't? We're interested in they do. And what is the population? All dentists. And you can sketch this out slightly different ways. Okay, I'm parsing the words this particular way, but you know, all roads lead to Rome. As long as you understand how to get these quantities and identify them, you're perfectly fine. So now we're ready to put it together. It goes parameter, population, category of interest. So pi is the percentage of all dentists that would recommend Colgate. I'm going to say a quick word about why this ad is disingenuous. What did Colgate actually do? When we talk about context, it has to do with data collection. We don't know how the data was actually collected, okay? And this variable, whether it's recommended, is very ambiguous. Here's what Colgate did. Colgate sent a survey to a bunch of dentists, you know, they got a random sample survey of these dentists. And what they did was they listed a number of toothpastes and said, which would you recommend? Well, some dentists would recommend, you know, a number of them. They might recommend Colgate, Crest, and Aquafresh, okay? So the ad leads you to believe that the dentists recommended Colgate as the one that they would use the most, right? As the one that was most highly recommended, as if they were rating, and Colgate was always recommended first. That isn't what it was at all. There were some brands of toothpaste, and I don't remember the study because it's been a while, that were actually recommended more than 80%. And so the FDA said, you're wording this in such a way that people think Colgate's recommended as being the best, it's the most recommended, whereas in reality, it's just one of several brands that most dentists would recommend. And they had to pull that ad. Okay, what sort of test are we doing? So it's pretty clear that we're testing a manufacturer's claim, right? We're not testing to see if a change occurred or if a population had a certain parameter, had a certain property. What is the alternative? What are we trying to prove? So the watchdog agency is testing to see if it's true. And again, whenever we're testing a claim, the alternative is always against the manufacturer. Remember what the alternative is. The alternative is the plaintiff. They're the person going against a defendant. And in a class action lawsuit, what would be the plaintiff? It would be a person that would be claiming Colgate did not meet the claims in their ads, okay? So this is clearly a case where we're testing to see if it's less than 80%. Again, the null can be equal to or greater than or equal to. Equal suffices. I think in the book, they just want you to put equals to. If you can prove equals to, you've proved greater than or equals to. And the equal sign is always with the null hypothesis. It's really important to understand. Okay, so now we're ready. These are our null and alternative. And again, the book might ask you to state the null as equals, and that's perfectly fine. Either way is acceptable. It doesn't matter. Okay. All right, good. So now let's move on to our reading quiz question. This has to do with the rat empathy experiment, and we've already seen the video, so we kind of understand what's going on. And it turned out in that experiment, 65% of 40 rats they ran in this experiment freed the other caged rat. So they had 40 pairs of rats, and 65% of the time, the freed rat liberated the caged rat. And what I want you to do is I want you to work out what pi is. So you're going to go through this process where you determine the context, okay? And you're going to figure out what pi is. And then you're going to determine what type of test is being performed. And in this case, you're going to figure out if it's testing a manufacturer's claim. And don't assume it's manufacturer's claim. I copied and pasted this, okay? So these are all possible, okay? Which of the changes occurred, and what is the alternative, and how would we write it? So again, determine the context, figure out what pi represents, what type of test are we interested in here? What is the scenario here? Number 2. And finally 3, work out the alternative, because the last part of the reading quiz is going to ask you to state the null and the alternative. And so this will be the first reading quiz question. Go ahead, take some time and do that.